Hi, everybody. So just to start things off a little bit, can everyone here, if you have ever had to reset, restore, rebuild, or repair some kind of persistent data that was needed for your service, could you just raise your hand for me? Yeah. And now, when you had to do that, how many of you were able to follow some kind of plan or instruction that was in place for how to do that? That's a good number of hands, not as many, but a good number. And how many of you were able to perform that recovery completely correctly on the first try? Only a few, yeah. So these are the kind of questions that worry me a lot. So I want to talk today about what recoverability is, what makes it hard, how do you have some recoverability, and how much of it do you need? And yep, so hi. I'm at Google now. I'm currently on the customer reliability engineering team, but before that, I've spent about half my time actually at Google on a data integrity team that spent a lot of their time worrying about these questions. So the recoverability game, obviously it is not an amusing pastime, it is a very serious topic. So why a game here? Well, because the most effective way to avoid losing at this game is to avoid playing it at all. If you have the luxury of having a service that it's a stateless service, you don't have a database, it's very exciting, then from the point of view of recoverability, you win. But often that's not an option. As we can tell already from the questions I just asked, it hasn't been an option for many of us. And so then when does recoverability apply to you? So there's two conditions. The first one is that you store persistent data. A lot of the time, this is going to be a database or some kind of blob storage. But it could also be the state of an internal stateful system, such as a messaging queue, or perhaps a partial state from a purchasing transaction system. Or it could be your production configuration, or it could just be some certificates or keys that you need in order to keep your service running. And the second condition is that when this data is incorrect, it has consequences. Right? So you have some data, so you have some consumers of that data. It might be some processing jobs or your external users. And they're going to want to get that data from you. And in the event that you give them something that is not what they wanted, then your processing jobs are going to do their typical garbage in, garbage out, just doing my job, creating a big mess. And your end users are going to be confused and upset and kind of unhappy with your service. And then to play this game in advanced mode, have large-scale data. It's very important to remember that data doesn't have to be big to be critical. A single bad certificate could bring down an entire service. But in the event that what you're talking about is taking care of a single certificate, a viable, maybe not good, but a viable solution might be to put it on a flash drive and put it in a desk drawer. Yay, done. But when you're working with large-scale data, you're going to have to work a little harder than that. Because recoverability is hard. Sometimes all the king's horses and all the king's men aren't enough to get it done. And the first thing I need to say about that is that redundancy is not durability, at least not on its own. Redundancy is a very well understood and important part of serving reliably and serving at scale, possibly necessary. But the problem comes when you start to write bad writes into this data. Because corrupted writes and deletes will replicate beautifully. Somebody writes a bad piece of data, and then it very happily propagates out to all your instances, and now what you have is a beautiful copy of bad data. So what then might be able to provide you with reliability? One option is to have rebuildable data. This is great when you have this option. Maybe you can rebuild it from input events. Maybe you can reacquire it from your content providers. It's not always a choice, and when it is a choice, sometimes it's expensive, either in time or in actual money. But it's good to use if you have it. Another option would be to have replayable changes. The most common example of this would be to have some kind of a SQL database that has a transaction log that lets you replay transactions. Again, not every kind of storage layer supports this, and even when it is supported, it might be expensive. It can take a really long time to try and replay hours and hours of events across a busy service. But an important thing to remember about replayable events is that they're often only replayable forwards. So even if you have this option available to you and you've got those transaction logs, you may still need some kind of way to go back to an earlier point in time so that you can replay forward from there. which leads us back to everybody's favorite solution for durability, backups, or possibly snapshots, or whatever name you want to give for a point-in-time recovery tool. So unfortunately, when it is time for a recovery, we find out that a backup is not a restore. So have you ever tried actually retrieving one of these backups? Do you know where the backups are being stored? You know you've been putting them somewhere. How long is it going to take you to remember where that is and how one accesses it? And then when you have found it, are you sure your backup process was working properly? So how many people, either through personal experience or through reading some kind of a postmortem, have seen a real-life example of this happening? They know they configured the backups, but they weren't in there when they looked. Yeah, it's a lot of hands. OK, but let's say the answer was that your backups were working properly. Hooray! Which one is the one that you need? Have you been keeping backups for a while? Are there a lot in there? Have they been meaningfully named or indexed? Do you know how far back to look? Is there any chance that you have been backing up more than one type of backup into the same storage location? And can you easily tell the difference between those different backups? Yes, you found the one that you need? Good. Are you positive the backup has what you expected inside of it? Maybe you set up the configuration, you're pretty sure that you're backing up the cat namespace, but oops, actually you were backing up the rabbit namespace. Or perhaps there was a mistake in the config and it didn't parse right and you were just creating empty files. Or how about this? You actually have been on top of this situation. You have a database, and 2 years ago you set up the backups for it, and you know it's been working. But last spring, somebody added a new table to the database, and somehow that table was never added back into the config for the backups. So you have everything in there except that table, and that's the one that you needed. So all backup setups are Schrodinger's backup until you open that box and see what's actually inside. And then say you have it. It had what you needed inside. Do you have room to unpack it? And this isn't just about needing the storage space, right? So it's been probably compressed and stored remotely, maybe in a different format. Maybe it has multiple things in it. You only want one of them, but in order to get it out, you have to unpack all of them. So you're going to need the bandwidth to get it from its cold storage location into a staging space. You're going to need enough space there to unpack it. If this is some kind of say a database snapshot, you're going to need enough database resources to use the memory and CPU resources it requires to get that data into a usable state. And all of that effort is going to take time, which is another scarce resource when you're in a recovery situation. So say that you've got all this under control. You have the backups, they were working, it has the data you need, you found a way to stage it, but you may still have some of the hardest work ahead of you because a restore is not a recovery. So I'm going to talk for a second about this picture. This picture is actually a picture of my own chandelier in my own house. And as you can see, it actually has lights out in the chandelier. Why would that be? We have the backup bulbs. There's one right there in the picture. And changing a light bulb is such an easy process. It's actually the basis for an entire genre of jokes. And yet we don't do this. And why not? And there are several reasons. One is that we need to have the right tools in place. In this case, what we need is a very tall ladder. That ladder has to be actually maneuvered into the room and assembled to its full height in the right place. And we're going to need the right safeguards. For instance, in this case, what we need is someone who actually understands the safety procedures for using a very tall ladder. And we're going to need to get all children and pets out of the area. And we also need careful planning. You can't see it in this picture, but there's also a staircase here. The positioning of the staircase is such that it's actually quite difficult to get the ladder into a position where when you're at the top of the ladder, you can actually reach the light bulbs. So having this staged restore is a lot like this. It's generally, you need the staging space. It's generally very recklessly impractical to try to put the data directly back into your service. Your service is probably still active, in fact. You're going to need a way to reincorporate the restore data back into the active service. And in order to do it, preferably without further disrupting it, you're going to need tools and safeguards and planning. So some of the things you need to remember when you do this planning is that a snapshot, one thing is a snapshot lives in the past. Your service is continuing to grow and evolve, and your snapshot is not living in the present anymore. So with some luck and preparation, your snapshot will be as close as possible to the present. But it's going to be different, and you're going to have to account for it. So as an example, One major primary cause for data incidents is problematic config changes and releases. So let's say that perhaps in order to work with a brand new feature that you're trying to release, you've changed the data format of one of your columns from being a string to an int. Probably sounds like a terrible idea, but it's been done. And actually, this caused a problem. Some of the data didn't transfer properly. So now you're going to need to get your backup and put it back in. But from your backup's point of view, that data type is still a string. You still are going to have to figure out how to get it from the old format into the new format safely before you can put that data back where it belongs. And also, most recoveries need to patch in only partial data. So luckily for us, the kinds of data incidents where you want to wholesale replace your database with an old version of it are pretty rare. I say luckily because that's extremely disruptive. And so when that's not the case, your service can continue to run with reduced quality while you're trying to resolve the data incident. That's good. But having to do a partial recovery makes our job much, much harder, right? We need to figure out which pieces we want to replace, how to extract them, possibly at large scale. I mean, maybe it's only a small percentage of your data, but if you have a few million rows and a few thousand of them have been affected, do you have the tools in place for specifying 1,000 specific rows and cells and then correctly and without damaging any surrounding data, extracting from the backup and putting them into your new service, back into your service? So just for a moment to go back to the light bulb example, in my chandelier, it's actually very easy for me to change all the bulbs individually if I get to the point where I can reach it. They're all made to work independently. But have you ever tried to change a light bulb in a string of holiday lights? You try and change one, and you start affecting the working conditions of all the others. And sometimes it's very difficult to even figure out which one is the one that was problematic in the first place. So another thing to worry about is that newer data is going to need to be re-merged in. This is something that I feel we can all relate to. How many people here have ever had a phone set up just the way that they wanted it and then lost or damaged it? Yeah. It's a very painful process. Things have been getting better. Right now you get a new phone, and a lot of the state has been saved, so you can just let it sit, and it's going to reinstall all your apps and things. But there's always something going on. Maybe one of the things you have to do is redo all your logins for all your apps. Maybe something that happens is you had that game where you were at level 152, and now it's reset you back to 0. Maybe there's some painful process you can go through to fix all that. But this is where you have to start to make choices. Where is the trade-off between this is the point where the cost of trying to get any closer to where we were in our actual state becomes more expensive than the cost of deciding that we aren't going to do that anymore. One more thing, the dependencies are going to need to be updated and repaired. So it's pretty common that you're going to have some kind of linked or dependent data. So if you have indexes, collected metadata, aggregations, any kind of caching, event sequencing, that it's very important that it be in order, all of those things are now going to be broken. And you're going to need a way to recognize all the places where they're broken and fix them. And the last thing, and something that we often forget, is that we also are going to need to let the dust settle. So in this picture, this horse that's running out of the picture to the side, that's you charging to the rescue to save your data. You've done an excellent job. You ran in and you rescued it, and everything is starting to work again. But that horse in the middle of the picture that's in the dust, that's your users. They're trying to use your service, and it's all been kicked up and disturbed, and they're having a really hard time. So we need to understand the consequences of the actions we're taking and make sure that we can account for them. What's going to happen if you force your database to rebuild all its indices out of band at once? Or what's going to happen if your storage layer is struggling to replicate a flood of writes at a scale that would normally have taken hours or days, and you've done them all in a few minutes? What's going to happen to your ability to handle large quantities of user requests? What's the experience going to be if the user is accessing, is being load balanced to different servers that have different states until the state has propagated completely. So that's a lot of different things to have to worry about. What are some things that we can do to prepare? The first step, step 0 really, is to know your storage. It's possible that in a perfect world that would go without saying. It feels like it ought to be easy. I mean, we all know what we're storing, right? But my experience has been that it is the rare team that can thoroughly answer this question unless I've really put some thought into it. So usually this is how the conversation goes. So what are you storing? Our primary data is our cat GIF repository and the metadata index. Yep, our primary data is our cat GIF repository and the metadata index and the user account database. Our primary data is our cat GIF repository, the metadata index, and the user account database. Oh, and the most popular GIF scores. Let me start again. This document is a full description of our primary data stores. And make sure in that document that you don't forget that one file. You know, that one that came from that hack that you did where now you have to have a file that goes with all your containers or whatever. If you don't have that file, the jobs won't start properly. Yeah, make sure you remember that one. Okay, so know your storage. You need to know what you store, where are you storing it, and how. What does your storage layer look like? What are its capabilities? Where does the data come from? Can you rebuild it if you need to? How long do you keep it, and why? What dictates the maximum and minimum time that you're allowed to keep it? Are there, for instance, any government regulations that help you decide when and where you're allowed to keep and transfer this data? All really important to know. Once you know all about your data, make sure you consider your recovery options. Remember, as we said before, it's not just backups. What can you rebuild? What can you replace? You wouldn't normally worry too much about data integrity for a cache, but it's a good example of a kind of data that the best way to handle it is just to, something happens to it, just throw it all in the garbage and start over. Not usually what you want to do with your data, but sometimes that is actually the right answer. And then once you are thinking about backups, you can back up strategically. You can use different tiers of frequency and retention to help use your resources more efficiently, so you can actually cover longer periods of time. If you have an incident that causes you to need to recover a piece of data from 3 weeks ago, you're not actually going to appreciate it if, since in between the time of then and now, you've been taking a backup every hour. That's going to be way too many. But if you're trying to recover from yesterday, then you might actually want hourly backups. So maybe keep the ones every hour for only a short period of time, and the less frequently after that. And you're also, as I've mentioned, going to need a tooling for all those things I said about why a backup is not a restore and a restore is not a recovery. And different data stores are going to have extremely different backup needs, and they're going to need to tailor your recovery to your service. So in the illustration here, the flowers represent some kind of short lifetime data. Maybe it's some kind of, I don't know, cookies or something that you only keep for a few days and then they're dead. The jewels represent some kind of long-term storage data. This is some kind of blobs that your users have given you or something that you need to keep this indefinitely. So metaphorically speaking here, it's okay to keep the flowers in the basket. Some kind of easy access storage place, right? It's easy to put things in, it's easy to take things out, it's not too far away when you need it, and if someone accidentally kicks it over, well, it's okay, we can deal with that. But you don't want to keep the gems in the basket, right? It's too easy for them to get lost. It's right? You want to keep them a little safer than that and a little safer from accidental interference. So instead, we're going to keep them in this vault. Their value is such that it is worth it to us to go through the extra expense of having that and of going through the extra trouble it takes to open it and close it every time we need to put stuff in and out. But I have intentionally chosen these abstract metaphors to be very far apart from each other, right? So it feels like a binary choice. But there's an entire spectrum of needs that data might have. So let's consider this instead. Maybe you have also a cake. The cake can't go in the basket or in the vault. It has to go in the fridge. Okay, now we have the fridge. Do we need the other things? It might be okay to put the flowers into the fridge. That could be fine. And maybe even the gems. It's better than the basket. I don't know. It depends on what your needs are, exactly what you require. So we've got some backups. You've thought about tooling for your restores. But you're going to need to also, if possible, prepare some validations. What does it mean to be valid? How are you going to know if your recovery was actually successful? This is actually a pretty difficult question, but it's really worthwhile to be able to do this, right? Because otherwise, you're not going to know about those times when your recoveries actually introduced new problems or didn't complete properly. But the bonus that you get out of that is that once you have the ability to validate whether things were correct, is that now you have a detection tool. So detection tools will let you do proactive consistency checking, right? Every time you have a config change or release, you can have this running to know whether or not bad things are happening to your data. You can catch the problem when it's relatively small, before it's been running for hours and propagating corruption throughout your system. So having all those backups and tools are part of having a recovery plan, right? A plan for what to do in different situations. Those instructions that I mentioned at the beginning that most of us didn't have when we had to do a recovery, we'd love to have that, right? So have one, have it documented, test it if you can, and ideally automate it. If you have all these tools and plans, why have a human sitting around doing it? Let it be automated. All right, so that's all about why recovery is hard and how we can plan for it, but I said I would help with managing it. And that means we're going to have to make some decisions. So to recap, the advice I've given so far is to catalog the storage, plan what to do when you need to recover, prepare the tools you need for it, test it, automate it. Oh, that is really, really a lot of work, a lot of work. So what are we going to do about that? Fit for purpose. So to go back to my chandelier example, I can tell you that I am not going to do all of those things, right? I've made decisions about what it means to me and what it costs to do something about it. And so I know my storage, and I have a plan for what to do if I have to do it. But I'm not going through all that, testing and automating. That's not going to happen. Why not? Well, what guides SRE choices? We start by adding together our business needs and technical constraints. We use that information to build SLOs and error budgets, and that gives us data and actual numerical parameters for assessing how risks are going to affect us. So looking at a perspective of our business requirements, this is what we might be asking. How resilient is my service to losses? What effect is the data incident going to have? So in order to answer those questions better, I need the SLOs. I think that probably most of you have heard something about SLOs already during the conference. There's been a lot of talks. But if you need to know more, the link here is to a talk by my colleague Liz Fong-Jones at Codis Craft, talking about SLOs and error budgets. Giving the 30-second version, SLOs are targets that we set through a collaboration of product management and SRE. Once you have that reliability target, you can take 100% minus that for your budget of unreliability or your error budget. You can use monitoring to measure the actual performance, and then use the data you get from that as a control loop for making data-driven decisions. So then if we take these questions again, and we think about them from an SLO perspective, we change now so that how resilient are we becomes what is our error budget for durability? What is our error budget for availability? And what effect will the incident have becomes what is the impact on that SLO and that error budget? And over what % of the service? But still, that doesn't give me to the question I needed. The real question I want now, and now I have the data I need to answer it, is how much error budget will an incident burn? And this takes me back to why I'm not going to do anything about my chandelier. It's because I've assessed what the impact is, right? It turns out that that's actually not the only source of light in that area. I can light the house just fine. And so I'm not that worried about it. And I could take my own advice. I could try uninstalling the chandelier, and now I don't have a problem anymore. Hooray. But I like the way it looks there, and I've decided that the problem that comes with it, the impact to my error budget, is acceptable to me. I've also decided that trying to install a mechanical system for raising and lowering the chandelier, or maybe inventing a complicated mechanical arm that lets me stand on the upper stair landing and change the bulbs from there. Those are things that are theoretically possible, but I'm not going to do those either. They would require a lot more design time and money and effort on my part than it would be really worth it. So it's going to stay the way that it is. I've made the assessment, and I've accepted that it has the impact to my error budget is acceptable to me. But we still need to do a little bit more practical evaluation of when choices are needed. How are we going to make choices about what are the right things that we can do and invest our time into making improvements? So here I've used the risk sheet. So again, I don't have time to go into full detail about that, but the link here is to a talk by another colleague, Matt Brown, from SREcon Americas, where he talks in detail about risk assessment in general and about this assessment sheet in particular. And here I've made up some possible risks I might put into it. So maybe an operator accidentally deleted the database and it has to be completely restored. Or a bug in my new release has corrupted 1% of all my writebacks. Or a timestamp bug in a new release has triggered a widespread premature garbage collection of my data and it's slowly being eaten. Or perhaps bad storage configuration change has truncated all the largest 5% of my entries. And I've made up some numbers that go with this. And my focus here, because this talk is about recoverability, is on the estimated time to recovery column. So just to be clear, the columns are time to discovery, time to recovery, percentage of the users that it will affect, estimated time between failures. And then the bad minutes per year is the calculation that the risk assessment sheet helps with. And I've put in two different numbers in the recovery column. And what I'm trying to do in this example is that the service that I'm pretending to evaluate here does not have a plan for how to do partial recoveries. So all the times I've put in for the time to recovery are very long. The time for replacing the entire database is actually the shortest time, because all the other ones involve first getting all the data back and then figuring out what to do with it, because we haven't made a plan. So right now, I've started to make a plan for what it would take to do this more efficiently. How am I going to do it? Can I have the tools in place? And looked at how much that's going to improve my admittedly a little bit estimated hand-wavy numbers, but at least now I have numbers. I have some way of doing a comparison. I wouldn't say that these numbers are going to give you the exact representation of what's going on, but this can help me give a relative comparison, right? So I can guess that this will have a big effect, and making this change will have what other improvement for me. And so when I'm using this tool, some of the things that to think about as I'm thinking about my cost versus risk trade-offs. This is something that I would like to go into more detail about. I think I'm going to try and write a blog post about this, and we can watch for that coming up. But just for now, at a high level, we want to think about, for tooling, the risk is that you won't have enough tooling, but the cost is that it is actually quite costly to spend developer time on making and maintaining those tools. Backup retention. The shorter the time that you keep them, the less time you have for performing a recovery before that data is lost. But the longer you keep them, the more you're going to have to pay for it, both in storage cost and in being able to index and maintain them. And then backup locality, which is a funny one. You don't want to have it too far away because it's going to be too long to recover, but you're going to have to pay for keeping it closer. It's generally, hotter, closer storage is going to be more expensive. But the flip side of that is that you also don't want to have it too close. You don't want to have it in a place where it's interfering with the availability or quality of your serving resources. And you also want it to be sufficiently independent that if you have some kind of a regional problem affecting the area where your serving is, the backups aren't in the same place. And then also recovery precision. You need to know from your SLOs what amount of precision you need for recoveries to satisfy your business needs. And then how are you going to achieve that? How frequent do your backups need to be? How much can you combine that with rebuildability and replayability, so that you can balance the precision with the amount of time it's going to take and the complexity of the process and the danger that introduces to the process. And so, to wrap up, recoverability is hard. Redundancy doesn't give you durability. Backups don't give you restores, and restores don't give you recoveries without extra work. You can be prepared. There are a lot of steps that you can take. You can catalog, plan, prepare, test, automate. And you can also make data-driven decisions about how much of that to actually do, right? How much recoverability do you need? How much of your time and money and developer resources are you going to put in to making this possible? And how much of it is necessary to bring your service to the performance level that you need? This is the video resources that I mentioned earlier. And of course, what SRE talk would be complete without a picture of the books. The books are amazing, as are their authors, so please check them out. And I want to say thank you to all the awesome colleagues who made this talk possible, all the time I spent on my data integrity team, and also with now the custom reliability engineering team. With a special thanks to Liz Fong-Jones for all her encouragement and feedback on this talk.